Hi, this is lecture 20. This lecture is going to look at a detail of a door threshold. So a door opening has some similarities to a window opening, especially at the head where the arrangement of lintels is also required. There are some significant differences though. A door needs to be located at or near floor level to allow for access, and this causes some complications when it comes to making sure the door is weatherproof. This lecture is going to look at the details surrounding the door threshold. So this is the detail that we're going to look at. It's taken from the Scottish Accredited Details, and it shows a ground-bearing floor with a cavity wall and a threshold and a foundation. So some of this has been repeated from previous lectures. The first part to do is to form the strip foundation. So this is a trench that's dug around the building, and into that is a concrete foundation. It's poured, and it depends on the size of the building, the weight or the load of the building coming down, and we would clear all of the topsoil from within the building. So it's fairly similar to the trench foundation lecture that we gave earlier. And up from the foundation we would build the substructure, and the substructure consists of an outside leaf and an inside leaf. The internal leaf is the load-bearing leaf, so it's probably thinner, and in between them we would fill that with weak concrete. Following that, we can backfill to the outside, usually with excavated material, but sometimes with gravel, and the inside would be laid with hardcore or MOT type 1, and that would be compacted in layers of 150mm. We would blind the top of the compacted subbase with sand, and then we would lay a DPM over the top of the sand, and that would lap up the wall and then be sealed against the DPC. Onto the outer leaf we would place a precast sill, so it's a concrete sill, and it's got a sloped surface to the top to shed water away from the house, and it would also have a DPC below and behind the sill, which could be a bitumen type material which is burnt onto those faces. Into the top there is sometimes a water bar, which is a little groove within the concrete in which a metal bar can be placed, and that helps to stop any water being blown back into the building. Internally, because we've got a little bit of space to make up, we would put treated timber packers, and they're sitting on top of the DPC, so there's no possibility of them getting wet, and they help to support the flooring sole board for the door. We can then insulate the inside. We can put rigid insulation over the DPM, and we would continue insulation up the face of the wall, lapping over the top of the timbers, and then pour our in situ floor slab. After which the floor finish can be laid. It's supported on the floor slab, but also fixed back to those timber bearers. Once we've got those things in place, the door and the threshold can be installed. The threshold could be a preformed metal threshold or a timber threshold, but it would cover the construction of the DPC, the timber, and the water bar. Externally, it's good practice to put a linear drain across the door to catch any water which does run towards the house, and that completes the construction of the door detail. So in conclusion, there are a couple of key points to note. The DPC to the underside of the back of the sill is commonly a bitumen-based material, which is burnt onto the required faces using heat. The water bar can be slotted into the top face of the sill and forms a vertical barrier against the passage of water. DPC to the inner leaf is lapped down and sealed over the DPM to create a watertight seal. And the threshold to the door should be a low-profile threshold capable of allowing a wheelchair user to enter unaided. External drainage across the door opening is required to protect the entrance from surface water. Okay, thank you very much for listening, and if you have any questions, please let me know.